Good day everyone. Today we're gonna answer a problem on fluid mechanics chapter 4, relative equilibrium of fluids. Let's start. A, an open cylindrical tank has a diameter of 3 meters and a height of 5 meters, and it contains water which has 4 meters in depth. Calculate its maximum angular speed in RPM if it should be rotated in its vertical axis such that there is no water spilled and h is equal to 2 meters. So we have a figure here, this cylindrical tank, and as you can see these broken lines here, this oval broken line is the original height of the water, which is 4 meters. And if the height of tank is 5 meters as stated in the given, and the height of water is 4 meters, therefore the height of air here above is 1 meter. And this paraboloid here, as we rotate the tank to its vertical axis, we form this paraboloid, and it is stated in the problem that the paraboloid has a height of 2 meters. Therefore, the height of the paraboloid reaches the top of the tank, but the water is not spilled. So we need to calculate the speed of rotation such that there is no water spilled in the tank and the height of paraboloid reaches 2 meters. Also, we have a 3-meter diameter here, and in order to solve the problem, as usual, we need to write all the givens we have. We have here the diameter of the tank. We have the height of the tank, which is 5 meters. We also have the height of water, which is 4 meters, and the height of paraboloid, which is 2 meters. In order to solve the problem, we're gonna use this formula, which h is equal to omega squared times r squared over 2g, in which h is the height of the paraboloid, omega is the angular speed, r is the radius, and g is constant, which is 9.81 meter per second squared. And in order to solve this omega here, we will cross multiply this equation, and now we got omega squared r squared is equal to 2hg. And we're looking for omega, so we will divide this both sides of the equation by r squared. So now we have this, and we can cancel r squared on the left side of the equation. And what will left is the omega squared is equal to 2hg over r squared. Again, we're looking for the omega, so it is raised to the second power, so we need to get the roots of both sides of the equation. Now we have omega is equal to square root of 2hg over r squared. And now we are ready to substitute all the givens we have. So we have h is equal to 2 meters, g is equal to 9.81 meters, and r is equal to 1.5. Substituting the value and simplifying this equation, we now have omega is equal to 4.18 rads per second. But we're asked to calculate the value of omega in RPM, so we need to convert this 4.18 rads per second to RPM by simply multiplying it to a conversion factor. And to convert rad into revolution, we need to multiply it to 1 revolution per 2 pi rad, and to convert second to minute, we need to multiply it by 60 seconds per minute. And then we can now cancel this rad, and we can cancel these seconds, and what will left is revolution per minute. And simplifying, we now have 39.2 revolutions per minute, or simply omega is equal to 39.92 RPM. And this is the final answer for our problem.